All right, guys, so today we are going over the review sheet. Tomorrow we are starting the test. So again, you can use your review sheet on the test. So anything you feel that's necessary or notes or stuff that you need, make sure to put them on the review sheet. I will have the transformation general forms up on the board for both parts of the test. Now for problems 1 through 8, write the inequality in interval form. So our interval form is our parentheses and brackets. We use parentheses if it's not included, brackets if it is. Negative infinity and infinity will always have parentheses. So we'll look at number 1 first. Now whenever we have two endpoints, x is in the middle, our two numbers that we're going to be using are the endpoints. Smaller number is going to go on the left. Bigger number is on the right. Now, we know to use parentheses or brackets are going to be because, or we know it by our inequality signs. Since the negative 256 is just less than x, it's going to have a parentheses. Since x is less than or equal to 100, equal to will tell us that it has a bracket. And that is it. Now, especially when we went through the notes, we graphed this. We put it on a number line. You do not have to. We put it on a number line to be able to visually see it and help us there. So that's all we'd have to do for number 1. We just wrote it in interval notation. Any questions on 1 through 4? We feel good with 1 through 4. Okay. We'll look at number 5. 6 is less than or equal to x. This is one of our unbounded. When we unbounded inequalities is going in one direction. Whenever we only have one endpoint, so because we only have one endpoint, it means we're either going to go to infinity or negative infinity, depending on if x is bigger or smaller than the number. So here we're saying 6 is less than or equal to x. X is going to be our bigger number. So that means we're going to go from 6 to infinity. If we're saying it's less than, x is less than that number, we're going to negative infinity. Infinity and negative infinity will always get a parenthesis. Infinity will be on the right side of the number. Negative infinity would be on the left. Smaller number on the left, bigger number on the right. Since infinity is bigger than 6, it goes on the right. Now for the parentheses or bracket with 6, since it is equal to it, we have a bracket. So it'd be bracket 6, comma, infinity. Questions on 5 through 8? All right. 9 through 14, we want to write each set of number in set builder notation. Set builder notation is with our braces. The first part is our group of numbers, bar, our description. If the group of numbers is all real numbers, we just go brace x bar. If it has something more specific, we fill that in. If it gives us an interval, we've got to change it to an inequality. So if we look at number 9, 24, parentheses 24, comma 87. This is a bounded interval with our endpoints at negative 24 and 87. With our bounded interval, we'll have x in the middle, so negative 24 is less than x is less than 87. Now we can go back and see which one's equal to, if one or both, or none. 24 is not going to be equal to it. Negative 24 will not be equal to it because it has a parentheses. 87 will be equal to it because it has a bracket. The only thing we did so far was just convert this from interval to an inequality. Because for us to put it into our set builder notation, we need it to be written as an inequality. Now we can go about actually writing set builder notation. So we have brace. x bar, because since it's an interval, it's the set of all real numbers. Set of all real numbers is going to be brace x bar. Our description for this one here is the inequality. So negative 24 is less than x is less than or equal to 87. Questions on number 9? Any other questions on 9? The other one from this set that I do want to look at is number 11. The set of all real numbers except for negative 2. Since it says a set of all real numbers, we know the first part, our group, is going to be brace x bar. If it says it's a part of the natural numbers, we can say brace x is an element of the natural numbers for whatever type it says. So since it's a set of all real numbers, we just go brace x bar. The description, all real numbers except negative 2. So that's telling us x cannot equal negative 2. Because if we have except a number, we just say x is not equal to it. The set of all real numbers such that x is not equal to negative 2. It can be any number but negative 2. Any other questions or any questions on 1 through 14? So the set of all integers, if we look at number 10, the set of all integers, x is greater than or equal to 200. So we'd say x is an element of the integers, is our z with a line, such that, now for this one here, they already gave it to us as an inequality, so we just have to fill it in. Intervals, we have to change to inequalities. If they already gave it to us as an inequality, we just fill it in. Natural numbers is our is the n with 2 lines. Natural numbers.
So do x equals lines bar?
Yes. So we brace x as an element of the natural numbers such that x is greater than 56. So x greater than 56 would be how we write this here. Now number 12 on the note or on the answer key, I accidentally left out the x as an element of the natural numbers, but that would be the correct answer for this here. Any other questions on this here? Be good with this here. Okay. 15 through 18, solve each system of equations by any method. So on the test, there are 2 systems of equations with 3 variables that you'll need to solve. You do not have to solve it by hand. You can use the calculator to solve it with our reduced row epsilon form. So I will go over solving this system of equations, how we would do it on the calculator, because if we did this in the calculator, we got to set up our augmented matrix. We make sure that each equation is in the form of x, y, z equals our number, and all 3 are. And we take the coefficients. So negative 1 for x, negative 5 for y, negative 5 for z, 2. Our second equation would be 4 for x, negative 5 for y, 4 for z, 19. 1 for x, 5 for y, negative 1 for z, negative 20. And this here is a 3 by 4. At this point here, we can grab the calculator. First thing we type in on the calculator is going to be second matrix. We go over to edit. And first put in the dimensions, which is 3 by 4, and type this matrix in. I'm on the right page. So -1, -5, -5, 2, 4, -5, 4, 19, 1, 5, -1, -20. Once we type the entire matrix in, we're going to go second quit. Second matrix. This time we're going to go over to math and find RREF, reduced row epsilon form. Second matrix A. And we'll hit enter. The two of these that are on the test are going to have a single solution. From top to bottom will be X, Y, Z. So X is -2, Y is -3, Z is 3. So -2, -3, 3 would be our solution. Yes.
How much is the grade, or how much is the score going to be?
It'll be 200 points. All of this, guys, this entire thing, you could type straight into the calculator. And if you don't know all the steps, I would go back and write all the steps. Yes, ma'am. We'll figure it out. We'll take it Thursday. Okay. We will go back over in a bit. We still have a bit more. So again, guys, I'll try, if we have time, I'll go back through these steps, but also, again, all these are up online. Yep, I will post this, yeah. And I will post a full video too.
So are we allowed to use that during our test, the video that notes and yeah?
So, review sheet. You're not going to have the video up.
You can have the review sheet though, right?
Yep.
Okay.
You can have the review sheet. Anything that you need on it, I would write on it. So the steps for the calculator, I'd write it out.
Are these exact questions going to be on the test?
Same questions, different numbers.
Probably.
So, all right, guys. So I would definitely go back through. There's only one of these that you're going to have to do by hand, and that's for bonus. You don't have to do it. The bonus is asking you to do these by hand. We'll come back to them. I want to make sure to get through the rest of this, then we'll come back to this here. 19 through 24, write the augmented matrix and state the dimensions. The variables have to be in order X, Y, Z, just like what we did on the last one. So if we look at number 19, are the variables in the correct order? Top one, X, Y numbered, bottom one, X, Y number. So our matrix going across the top would be 7 for X, -41 for Y, 29. Our second equation would be 46, -2, 19. Questions on how we wrote that matrix? What are the dimensions? Rows by columns. So we have how many rows? 2, 3 columns. So it is a 2 by 3. Questions on number 19? There we go. Questions on number 20? Well, let's look at number 20. First equation. 6x plus 4z equals 2. So 6x, 4z, 2, they're in the correct order. The middle one, we have y minus 7x plus 4z. The y and x are switch, so we need to switch them back. So because the x is -7, we have minus 7x. The negative is going to go with the x. Since there's not a sign in front of y, it will be positive. And our last equation is in the correct order. 6x minus y plus 3z equals 20. Questions on setup before we start plugging numbers in. Now the first equation, we have 6 for x. We do not have a y value, so it will be 0. 4 for z equals 2. Our middle equation would be -7 for x, 1 for y, 4 for z, and it equals 15. And our last equation would be 6 for x, -1 for y, 3 for z, and 20. Just because there wasn't a number written in front of either one of these y's, it is going to be 1, and the sign will be whatever sign's in front of it. So the last y was -1, the middle y was +1. Now the last thing we need to do is our dimensions. This here would be a 3x4. Questions on 19 through 24. We feel good with 19 through 24. If one of the equations has one of the variables, the other two need it as well. We're ready for the next set. (25 through 31, 25 through 29). We want to perform the following transformations to the function. There will be vertical translations, horizontal. We'll move it up, down, left, right. We will have reflections, and we will have vertical stretch or shrink. I am not putting horizontal on the test. That's also why I did not list it on the whiteboard. But with any of these transformations, take them one at a time in the order that they are listed. So if we look at 25, 25 says we have a translation up 3 and a vertical stretch of 2. Now our translation up and down, the general form is f of x plus k, where k is the amount we move the function up or down. Since we're moving up 3, the value of k is +3. At this point here, we still have f of x, so we're going to replace it with its function. Notice that we have 6x squared minus 1 plus 3. We substituted f of x equation in for f of x. Now at this point here, we don't need the parentheses. We have 6x squared minus 1 plus 3, which tells us our new equation after our translation up 3 is 6x squared plus 2. And for this point here, we can call this g of x. So we've only done one transformation. We did the translation up 3. We still need to apply a vertical stretch of 2. Our vertical stretch or shrink in the general form is a times f of x, or here we're going to say a times g of x, because we're applying it to the function g of x. With our vertical stretch or shrink, the value of a is exactly what they give us. Since it's a vertical stretch of 2, we're going to replace a with 2. Now that we've set the general form up, we'll replace g of x with its function, 6x squared, telling us that we have 2 times 6x squared plus 2. Last thing we need to do is distribute the 2. So our 2 times 6x would be 12x squared, and our 2 times 2 is plus 4. And we can call this h of x. It really doesn't matter what we call it. But our final function for this here is going to be 12x squared plus 4. Question on number 25. No questions on 25? The other one I want to look at is 28. F of x equals the absolute value of 4x minus 3 plus 2. We have a reflection across the x-axis, then translated up 4. Reflection across the x-axis is our negative f of x. So we'll start there. We'll start with its general form. Now, since we still have f of x, we'll replace it with its function, giving us negative times the absolute value of 4x minus 3 plus 2. Once we have this here, we'll multiply the negative through by our absolute value. Now the negative will not go into the absolute value bars, so it'll stay out front. That's the same with vertical stretch or shrink. That number we multiply through, if we multiply it by an absolute value, it stays in the front. Now we also have to multiply that negative with our positive 2, giving us minus 2. So our reflection across the x-axis will give us negative absolute value of 4x minus 3 minus 2. That's all we had to do for the reflection across the x-axis. Now our translation up 4, again, we're going to go with our vertical translation form, which is normally f of x plus k. But since we're not applying it to f of x anymore, we're applying it to g of x, the one we just did this to. We get g of x plus k, where k is the amount we move it up or down. Now, since it's going up 4, the value of k is positive 4. If it was going down 4, the value of k would be negative 4. Then again, at this point, we're going to replace g of x with its value. We can drop the parentheses, giving us negative 4x minus 3 minus 2 plus 4, which gives us our final equation of negative absolute value of 4x minus 3 plus 2. If you're not worried about 30 and 31, they will not show up because I'm not doing horizontal stretch or shrink on the test. Any other questions on our transformations or one of those that you want to see? Yes, sir. So we have to distribute that negative through the whole thing. So the reason that it turned from positive 2 to negative 2 is we had to distribute that negative sign to both terms, to every term. It's outside, yes. Because really we don't write it, but we're really saying we're multiplying everything by negative 1. So that negative 1 times our absolute value is just negative 1 times the absolute value. And our negative 1 times positive 2 would give us negative 2. Yes, ma'am. I will get those in a bit. Any other questions on 28 or any of our other transformations? We go with the transformations. And again, I would stick to those general forms and apply it. When we plug in h and k, again, plug it in with its value. If it's up or down, up is going to be a positive k value. Down is negative. H, if we're going to the right, it's going to be positive. If it's going left, it will be negative. So right 4, h's value is positive 4. Left 4, h's value is negative 4. And replace it and resolve our signs. Yes.
Bigger or
Yes. Now the numbers are going to be a little off here, but 30, 32 on your paper, we can look at it. So here we're multiplying by a scalar. So we're going to multiply everything in that matrix by the scalar. So we'd have 1/4 times 16 and 1/4 times 24. 1/4 times 30 and 1/4 times 9. We're multiplying everything in that matrix C by 1/4. 32. Is that the same problem? Yeah. Problem number doesn't matter, but same problem. Just the numbers are a little different. Questions on what we've done so far? Now at this point here, you can do this by hand or you can grab a calculator. And we can say 1/4 times 16 is 4. 1/4 times 24 is 6. 1/4 times 30 is 15/2. And 1/4 times 9, 9/4. 4, 6. 15/2. 15/2 and 9/4. If you give it to me as 15/2 and 9/4, that works. If you give it to me as 7.5 and 2.25, that works. As long as it's the same number, I will take it. Now, if it gives you a repeated decimal, I would rather have it as a fraction. 1/3 over 0.3 repeated. And with most of this here, we can hit the 2 arrows, the button above enter, and it will convert it back to a fraction. Questions on this one here using the scalar? Do we want to look at 33 or 34 next? 33. So you're 31. This one here is the one you want to look at? Okay. So adding or subtracting, to be able to add or subtract, the dimensions have to be the same. Now, when we did this here, and especially in class, we did the first two here, got our results, and then added it to the third, yes? We can do this all at once because our corresponding elements, so we would say 2 minus 1, yes? And then we would add to it 3. So you could do the first two and then subtract the first two and then add the third to it, or we can just look at each element, add and subtract as we go through it. Our next one would be 7 minus 4 plus 8. Our next one would be 9 minus 16 plus 7. And we have 8 minus 27 plus 2. If that is too many numbers to keep track of, do it 2 and then add the 1 in. Do it part by part. Now at this point here, again, just like we did the previous one, you can type each one of these sets of elements in. So you could do 2 minus 1 plus 3 in the calculator, and it would give you the answer. 2 minus 1 is 1, plus 3 is 4. 7 minus 4 is 3, plus 8 is 11. 9 minus 16 is negative 7, plus 7 is 0. 8 minus 27 is going to be negative 19, plus 2 is negative 17. And we get this here. Now you could have plugged these in as A, B, C into the graphing calculator and gone matrix A minus matrix B plus matrix C, and it would have given you the answer. Question on these two here. Questions on 32 or 33 or 34 or 35 on y'all's paper. Y'all feel good with these here? What's the answer for 35? No solution, not possible, undefined. Any of those. It does not work. There might be one of those on the test. So do make sure to check your dimensions. What are the dimensions of the first one? So dimensions. What's the dimensions of the second one? Are they the same? So can we add or subtract? No. Normally I do not put no solution on any of the tests, but this here, because it is just look at it. Yes, I'm going to put that one there. This is one of the few I will put on there. So the systems of equations will have solutions. 33, there might be one like this on the test, so check the dimensions to see if we can add or subtract. And there's only going to be one of them if there is one. Yep. Questions on 36 or 37? $35 or 38 through 40. Y'all want to look at, let's look at 39. On the test, you're just going to have to write the equation of line. You will not have to describe the slope. So to find the equation of line, we need to find the slope and then plug it in. Equation of for slope, y2 minus y1 over x2 minus x1. Now they did give us 2 points. They did not tell us the y-intercept, so we can't just plug it in as y equals mx plus b. So our two y values are going to go on top, 90 and 40. The corresponding x value for 90 is 40. Corresponding x value for 40 is 15. Now at this point here, you can plug that into the calculator, because it will do 90 minus 40 over 40 minus 15 and give us our equation or our value for the slope. 90 minus 40 is 50. 40 minus 15 is 25. And 50 over 25 is 2. Now at this point here, to find the equation of a line, we can use our point slope form. Now our point, we can pick either one. I'll pick 15, 40, so we'll plug 40 in for y, 15 for x, because each point is in the form x comma y. Now at this point here, we just need to get y by itself. First thing we can do is distribute the 2. 2 times x is 2x. 2 times negative 15 is negative 30. Last thing we need to do is get y by itself, so we're going to add 40 to both sides. And that will tell us, because negative 40 plus 40 is 0, leaving y by itself. 2x, negative 30 plus 40 is plus 10. So we had to find the slope and the equation of line. Questions on this one here? Yes. Lunch ends at 11:54. 1119. Questions on number 39? We're ready to look at the last one, number 40. With the last problem here, again, the first thing we would have to find is the slope, plug it into point slope form, and we get the equation of the line. Now here, we do have 2 points. One of them is here, bless you, at 0.65. The other is at 5.65. So our slope, y2 minus y1 over, bless you, x2 minus x1. What are the two y values? 65 and our two x values are 5 and 0. Now you could plug this into the calculator and it would simplify it for you. But if we do it by hand, 65 minus 65 is 0. 5 minus 0 is 0 divided by 5 is 0. We can have 0 on top of a fraction. We cannot have 0 on bottom. So the slope for us is 0. Now we can still have an equation of a line. We will plug 0 in for slope. I'll pick the point 65.5. So we'll plug 65 in for the y value because that is the y value of the point, 5 for x. Left side, we'll still have y minus 65 is equal to x times 0 is 0, x times negative 5 is. So the entire right side of the equation is 0. Now, even though the entire right side became 0, we can still get y by itself. We would add 65 to both sides, telling us y is equal to. And that's our equation. It is a flat line at y equals 65. Any other questions on any part of the review sheet? Questions on the calculator? Yep. If you want to grab one, we'll go back over 16. We good to move back to 16? Yes? Okay. So I'm going to go back through number 16 on how to plug this in. So if you want a calculator or want to write these steps down, it might be helpful. First thing we want to do if we're solving this by the calculator is to write it as an augmented matrix. So our number's going across the top. All right, guys, let's focus in. So x, y, z, negative 4, negative 5, negative 1, 18. Our second row, negative 2 for x, negative 5 for y, negative 2 for z, and 12. Last row is going to be negative 2 for x, positive 5 for y, positive 2 for z, and 4. And again, this is a 3 by 4. Once we get that written out, we'll pull the calculator up. First thing we have to do is plug the matrix in. To plug it in, we're going to go second matrix over to edit. We'll put it into the first matrix A, so we're going to just hit enter. First thing we want to type in are the dimensions, which is going to be a 3 by 4. And we'll plug each of the elements in. So negative 4, negative 5, negative 1, 18. -2, -5, -2, 12. -2, +5, +2, 4. We're going to type the whole thing in, and hitting enter after each number is helpful. And make sure on negative numbers we're using the negative sign, not the minus sign. Once we get it all typed in, we're going to go second quit. Now we need to get RREF, and to get it, we're going to go second matrix. Over 1 to math. Up or down to find RREF. Once we do, we'll hit enter. Now we still need to recall the matrix. So we'll go second matrix. If you put it in matrix A, we just have to hit enter. So you should see RREF, matrix A. Hit enter. Top to bottom on that last column will be XYZ. So -4, 0, -2. So the answer is -4, 0, -2.
So I type second quit and I use.
Second matrix. Over the math, we want to find RREF. Second matrix A. And we get this here. So second quit, then we go second matrix. -1, 18. -2, -5, -2, 12. -2, 5, 2, 4. Second matrix. RREF, second matrix. A. And I'll talk to you more here in a minute. But all right, guys, so your test, part 1 of your test is tomorrow.